All right. Stop. Would anybody like to present their case? Sam.
If you order a pizza and you don't take toppings on it, you're still getting cheese.
All right, that is Sam's argument. So Sam's argument is that cheese is indeed considered a topping. It's part of the pizza. Okay, so you say cheese is not a topping, it's part of the pizza. Okay. Would anybody like to rebut? Which is disagree. Nathan? Well, that's the argument then, isn't it, Jacqueline? Is extra cheese a topping that you would pay $1.50 for? Rylan? Well, no, it can't be. Here is why. My argument. If you do not put cheese on your pizza, you do not have a pizza. You have bread. No, that is bread. When you get your toast out of the toaster, do you eat it dry? No, you spread something on it. Right. I disagree. It is cooked bread. Toast needs butter, at least. Now, sidebar, argument that goes on in my house all the time. You put a piece of toast into the toaster. I lie. You put a piece of bread into the toaster, because if the toast was already toast before you put it in the toaster, then you wouldn't use the toaster. So you take a piece of bread, you put it in the toaster, and you feel you're going to put some peanut butter on your toast. Do you, when the toaster pops up, spread butter or margarine first and then your peanut butter? Or do you go straight peanut butter straight on the toast with no butter layer? I am very serious about this. You guys are giggling. How many of you are peanut butter right on toast, no middle layer?
Okay, so are you saying that you put peanut butter on your bread, or are you putting peanut butter on your toast? David, I thought you were brown. How are you eating that?
And how many people would put a layer of butter or margarine before their peanut butter? No one. Really? Interesting. I do, yes. Butter, then peanut butter. You're entitled to that opinion. You are all aware that if you eat a peanut butter cookie, it's chock full of butter. Okay, just making sure. Why is butter in the peanut butter cookie? Because butter tastes good. The only other person I know that insists on a layer of butter between the toast and the peanut butter is my cousin. My cousin-in-law, my wife's cousin. He's like, of course you put butter on first. Then it's decadent and yummy. Otherwise, it's just something you give an 8-year-old. That's his argument. All right. Thank you, ladies and gentlemen, for indulging me. Now, some of you are, of course, from other countries where you do not eat peanut butter on toast, right? Okay. Let's do some math, shall we? I know it is Monday morning, but you have had one block to warm up your brain. So when I ask this first question, should I hear the sound of crickets chirping, or should I hear the sounds of my bright and brilliant students hollering out answers, so many that I cannot choose who to ask? What will I hear? The first one. What should I hear? The second one. All right, here we go. Pizza Hut charges $12 for an extra large cheese pizza. Each topping costs $1.50 extra. Draw a graph to represent the cost as a relation of the number of toppings. So, if I'm going to draw a graph, how many variables do I need? 2. A few people said it. Excellent. What are those 2 variables entitled? Oh, we have an argument here. Well, you said independent, and somebody else said X and Y, and somebody else said toppings, and cost. Are all three of those answers correct? Yes, they absolutely are. All right. Now listen to my question again. What do we call those two variables? So Satjot is correct at first. We start with an IV and a DV. Now, what is the IV? Toppings. Why?
Because the more toppings there is, the more price.
The price depends on the amount of toppings. Excellent. So the DV must be the cost. And now Jacqueline will tell us her part to make it right. The toppings go on which axis, Jacqueline? The domain. Oh, you sneaky little, stop it. I was not expecting a domain. Ooh. And why? Well done. Oh, that was, I'm going to take a celebratory sip of my coffee that one of my students came up with domain there when I was expecting X. No, of course not. Excellent. So down here, toppings. And we should give it a name, right? T, excellent. And down here, what? Cost. In dollars. Excellent. What is if I get a pizza with 0 toppings, remembering cheese does not count, how much will I pay? $12. So where's the first dot on my graph? That's only one. A graph needs 2 coordinates before I can put it on the graph. 0, 12. Excellent. 12 and 0. And is that an included dot? Yeah, because if I buy that pizza with no topping, I'm paying $12. Right? Everyone agrees? Okay. If I get 1 topping, and I'm only going to go up to 4 toppings, because, of course, any more than 4 toppings, your pizza is then gross, no matter what anyone says. Right? Those everything pizzas are all but the cooked pizzas or whatever you want to call them with 75 toppings, so the pizza's like that thick, and you pick it up and it just basically looks like you cut a middle piece out of a lasagna. 4 toppings. And, of course, those toppings are pepperoni.
No.
Rylan, I am deducting you gummy bears. You are paying a fine for naming the worst pizza topping ever created. Pineapple has no place on a pizza. And do you want to know something that I bet none of you know? The Hawaiian pizza was invented in Canada.
Do you eat pizza with ranch? Or with ranch?
No. Dipping in ranch is fine. Who? No. All right. Yes, pepperoni. Kezia? Peppers. I'll allow it. Bacon. Yeah. Ham? Ham and bacon? Really? Are you allowed to eat ham and bacon?
Yeah.
Oh, okay. Olives?
Yeah, olives is good.
No! Olives taste like little washers. You're crazy in the head. Mushrooms? Mushrooms is one of those ones that you love them or you hate them. Yeah, sausage is nice on a pizza. If they break them into the little bits. But like at Boston Pizza where they just slice the sausage, put on those giant slices of sausage, I don't like that. I like my sausage broken down into little bits. Pepperoni, yeah. I have 2 kinds of pizza I go for. I either go for a pepperoni, ham, bacon, and then sometimes sausage if I'm in a meaty mood, or pepperoni, sausage, mushrooms, peppers if I need some veggies because I'm feeling a little, around the middle. And then sometimes I get chicken, feta, spinach, and tomatoes. It's so good. Don't laugh until you try it. Kezia? No, I haven't had the barbecue chicken. Oh, and one time I was watching that show Carnival Eats. Have you guys ever watched that show? and they had a buffalo chicken pizza. And what they did, Sage, no, wait for it. Instead of tomato sauce, they took buffalo wing sauce, like Hank's Red Hot, right? Or Frank's Red Hot, mixed it with ranch dressing, and that was the sauce instead of tomato sauce. No. And then on the top was a couple of kinds of cheese, and they took chicken strips and cut them up and put that on top. I made that for my daughter. It was actually pretty good. All right. Where is our next dot? That's only half a coordinate. Reverse it, because what goes first? 1 and 1350. Where's 2? 15, 2. And where would 3 be? 1650. And we're going to stop there because I went off the graph. Everybody cool? All right, now let's think about yesterday. Is this discrete or continuous data? It is discrete. Why? You can't get half a topping. You can say I want topping on half my pizza, but they'll still charge you for the topping. Right? If I go up at half, do I get any output? No, because the only outputs I can get are 12, 13, 50, 15, 16, 50, 18, 19, 50, 21, and so on and so on and so on. Everybody agree? So I can't connect the line, yes? Because this is discrete data. Everybody cool? Or data, depending on how you want to say it. Weirdly, I say data when I'm talking about my phone, but data when I'm talking about this stuff. I don't know why. I don't know why. I don't get it. So, all right. So, it is discrete, so there is no line. Now, no, we cannot go back to arguing about it. All right? Now, ladies and gentlemen, linear relations, as we have, this page is entitled, come in 4 manifestations. The first way we write it in words, which is written up at the top, right? 1 topping, $12 pizza, $1.50 per topping. That's one way we can do it. All right? So this is when we use the sentence, which I have written at the top. The second way we can show it is on a graph. Now here is where it gets something weird is going to happen here that for some reason really boggles your people's minds. So a graph, now remember, a graph can be discrete, which means what does the graph look like? A line or a series of dots? This is dots. Or it can be continuous. And continuous means what? Which is a line. Now, look at the name of this page. Linear relation. You see right there, it's got the word line in it, yes? But please notice, if it is discrete, there will not be a line. But it can still be a linear relation. And I'm about to show you why. I'm going to highlight discrete. I'm going to put a little question mark there, because how can it be a linear relation without a line? This is how. How far this way did I go? 1. How far up? 1.5. How far this way did I go? 1. How far up? 1.5. How far this way did I go? 1. How far up? 1.5. So, because this is repeating, we can predict what the next dot will be, yes? It will be 4, 18, right? So this part right here, and I've been highlighting in yellow, that is what makes a linear relation. And what it means is that each change in the IV results in the, not the same, what's the word I'm looking for? In the proportional change in the DV. So 1.5 in the IV goes up 1.5 in the DV. If I go 2 on the IV, I would go up 3 on the DV because the proportion has to stay the same. Everybody cool? We've already talked about this as, what do we call it? When we were doing the speeds and the velocities and such, a rate of change. This is a linear relation, has a constant rate of change. Now that's weird to write, isn't it? How can something be changing but be constant at the same time? This, right? The amount of change is always the same. Over 1 up 1.5, over 1 up 1. For how long? Forever? I could put infinite toppings on a pizza? You technically could, but let's be honest. Ain't none of you going for a pizza with rutabaga on it. Shut up. None of you want a pizza with Brussels sprouts on it. Shut up. None of you like Brussels sprouts. Don't give me that. There is a range of acceptable pizza toppings, yes? All right. No, pineapple is not in. All right, so that's 2 of them, yes? Right? 2. I said that there's 4, right? So let's cover the next 2. Table of values. This is the one that you know from the 9th grade. This is 3. Except in the 9th grade, you drew it like this, yes? But now we don't use X and Y because we recognize we can put any kind of data on a graph, yes? So what should we put instead of X and Y? IV, DV, and in this case, what would we put in IV? Toppings, and over here, cost or dollars. Everybody cool? Now, topping 0, cost 12. Topping 1, $13.50. Topping 2, $15. And we see that the change here is +1, and here it is $1.50. And then it repeats. Now, is one repetition enough to say it's a linear relation? No, because any 2 points have a change, don't they? I need to check if it happens a 3rd time. 3, $16.50. And because it happens 3 times, we know it's linear. Everybody cool? Now, the last way is an equation. And you can get the equation from the words, from the graph, and from a table of values. Okay? I find it easiest to get it from the table of values. Okay? I'm going to show you how to do it. Then I'm going to show you a little shortcut that's really helpful. Okay? So, start the table of values again. Toppings, 0. Cost, 12. Yes? Okay. If there is 1 topping, do I still pay that original $12? Of course I do. But I add how much? $1.50. Agreed? Okay. If I have a second topping, do I pay that original $12? Yes. But now I'm adding $1.50 times 2. Right? Because I've had a second topping. If I have a third topping, do I pay that $12? 12 plus $1.50 times 3. What if I add T amount of toppings? I pay the $12 plus $1.50 times T. Everybody cool? Everybody see how it works? Pretty easy, right? Now I know that cost equals 12 plus 150 times t. So if I wanted a 4-topping pizza, 4 times 150 is 6, 12 plus 6 is 18, and it would be right. Everybody cool? Now there is a little shortcut to this. Please notice all these 150s were attached to the t, yes? And all these 1s are attached to the cost, yes? 12 times 1, 12 times 1, 12.1. So if you get all of these to 1, then this goes there, and this goes there. And you get cost equals 12 times 1. Would we ever write times 1? No. Plus 150 times t. Does everyone see the shortcut? Now, please remember, that shortcut only works if these are all 1s. What do you mean by that, Mr. Myers? Observe, don't write this down. I just want to show you something. Is that a linear relation? Let's check. Plus 1, plus 2, right? Plus how much? 3 plus how much? 6. Is it linear? Yes, of course it is. Why? 1 went up by 2. Now I've gone up by 3, so this has multiplied by 3, correct? Did this multiply by 3? So it's linear. Why? Well, if I went up to 2, what would this be? 6. If I went up to 3, what would this be? 8. If I went up to 4, what would this be? 10, and then 5, 12. 1, 2. 1, 2, 1, 2. Does everybody see how I would eventually hit 512? So you have to be careful. These, if they're all the same, and these are all the same, then it's still linear. So what if I gave you this? Is that linear? How much did I go up there? 2. How much did I go up there? 5. There's 2 points, right? If I have a third point, I know it's linear. How much did I go up there? How much did I go up there? 5. Now, let's stop and look at this for a sec. Are all these 1s?
No.
So I can't do my little trick, can I? Or can I? When they were 1s, the 1 went with the y, right? So what would happen if the 2 went with the y? I'd write 2y, yes? Equals, and where do the 5s go? With the x, right? Yeah? Now what's wrong with that?
You don't know the numbers?
What's wrong with that as an equation? Which of those is my output? X or y? The y is my output, right? How many outputs do I want? 2 outputs or 1 output? 1 output, correct? So how would I get rid of that 2? Divide by 2. What would I have to do to this side? Divide by 2. And then 1 output would equal 5 over 2x. Everybody understand? Everybody cool with that? Okay. So linear relations exist in 4 forms, yes? Right? Got them all there. 1, 2, 3, 4. A linear relation. How do I know it's a linear relation? What is the thing I have to check? When the rate of change is what? is constant. So my x change divided by my y change, y is up and down, are always the same. Everybody understand? All right, let's turn the page over and prove it. Here's our first one. How much did I go up by there? How much did I go up by there? 9. How much did I go up by there? 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 Linear or non-linear? Linear. Easy peasy lemon squeezy, yeah? Right? So simple. What about this one? How much I go up by? How much I go up by? How much I go up by? Looks good so far. How much I go up by? 75. How much I go up by? A lot more than 75, right? 2,925. Is that linear? No. What about B? You got a 50-50 shot. It is. Why? What happens to every x? Multiplies by 2 and then adds 4. No matter what I do to x, the y is going to be 2 times bigger plus 4, correct? No matter what. And let's just prove it. X, y, 1, 2, 3. What's 1 times 2? Plus 4? 6. What's 2 times 2? Plus 4? What's 3 times 2? Plus 4? 10. Is it linear? 1, 1, 2, 2, linear. What about this guy?
Yes. It can be.
We're fitty-fitty. All right, let's check. 0, 1, 2. What's 4 times 0? Sorry. Bed mass. What's 0 squared?
0.
Plus 4? 4. Not times 4. 0 squared times 4 is 0. Minus 1? Negative 1. What's 1 squared?
1.
Times 4?
4.
Minus 1?
3.
3. So, okay, I went up by 1. I went up by 4. Can I say it's linear yet? No, because I need 3 points, right? What's 2 squared?
4.
Times 4?
8.
4 times 4 is 8.
Oh, no.
16. 16 minus 1? 15. Linear? Non-linear. Now, look at those two equations. What is the only difference? There's an exponent. If it happens once in math, how often does it happen? Always. So if there's an exponent, is it a linear equation? No. Everybody cool? Sweet. Let's look at D. Linear or not linear? It appears linear. Let's have a look. How would I know?
Oh, wait, because it's a line?
How would I know? How did we know here? I made the stairs, yes? Well, let's check. Do I make the stairs here? Let's start right there. And let's go down to there. I went 1 to the left and up about 1.5, right? Everyone agree? Okay. So there's my 1 change there. Yes? How far down did I go? 1.5. So, is it linear?
You gotta try one more time?
No, because I have 3 points, right? Hell yeah? 1, 2, 3. In a table of values, I need 3 points. But on a graph, I only got to prove it twice, right? Everybody understand? But I could go one more, right? If I go 1 over here, I'm a little bit off the graph. I go up, I'd be probably the same, right? Everybody cool? Okay, what about E? Yeah, it is. Why?
Because it has a movement.
When I go over 1, I go up 0. When I go over 1, I go up 0. When I go over 1, I go up 0. So it's linear. Because no matter what, I'm not going up, am I? What if I change it to this one? Is that linear? Yeah, because I go up 1, but I don't go right or left at all. Next one, next one, next one. Everybody cool? Sweet. What about F? No, of course not. I can see. It's curvy. What about G? Oh, I just gave away G. I forgot I had that example there. Linear. All right. And the last thing we're going to do is make a table of values and we're going to graph.
What about? Oh.
Now, you already know from looking at these which one is linear.
Left.
A. X, Y. How many points do I need? 3. Who chooses what points to use? You do. For some strange reason, when I'm teaching grade 9 and I say to the kids, okay, I'm going to make a graph. I'm going to use 0, 1, 2. They're like, Mr. Mars, how'd you know to pick 0, 1, and 2? What? Oh, I never know what to start with. What? And this is at the end of the lesson. X is the independent variable, right? The independent variable is the input, right? Who decides what to input into anything? You do. Here's a keyboard. How do I input stuff on it? I type. If I want to input the word the, where do I start? T. What if Helia wants to input the word onset? Where should she start? O. See how she decided to start with O because she decided on the word? My grade 9s are like, I never know what to put. How do you know what goes in the X column? I don't know what to tell you, kid. All right, so what's 0 times X?
0.
Plus 4?
4.
What's 1 times 2?
2.
Plus 4?
6.
What's 2 times 2?
4.
Plus 4? X, Y, X, Y, X, Y. Put them on the graph. Now, since it's linear, and I'm going to zoom back in on it now, since it's linear, and I've only got these 3 dots, over 1, up 2, over 1, up 2, what would happen to the left? I would go down 2 and left 1. Down 2, left 1. Down 2, left 1. How long will that pattern continue? Forever. Is this continuous or discrete?
Continuous.
Continuous. Because X can be any number, couldn't it? I can take any fraction, multiply by 2, and add 4, can't I? So this would get the line. Everyone agree? All right, now I'm going to change this. It's not X and Y. It's now toppings and cost. What's that line look like? Same line, same numbers. Can I do the line?
No.
No. Why?
It's discrete.
It's discrete. Can't have half a topping. Kids in the classroom, could I have the straight line?
Yeah.
For kids, if this was kids, I can have half a kid?
Oh no.
No. Right? Everybody understand? So remember, discrete can still be linear. Now, what about this other one? We know it's not linear. X, Y. I'm going to change things slightly here. I'm going to go -2, -1, 0, 1, 2. We're going to use 5 points. And there's a reason for this. This is kind of showing you what's coming for you. What's -2 squared? Negative 2 times negative 2 is negative 4?
Oh.
4. What's 4 minus 3? 1. What's negative 1 squared? 1 minus 3? Negative 2. What's 0 squared? 0 minus 3? Negative 3. What's 1 squared? 1 minus 3? Negative 2. Hey, wait a minute. What's 2 squared? 4 minus 3? 1. Hey, wait a minute. Goes back up. Negative 2, 1. Negative 1, negative 2. 0, negative 3. 1, negative 2. 2, positive 1. It makes this pretty curve. And that is what is called a parabola. You will become very good friends with them next year. And in physics. If you haven't done your physics in science yet, if you're in Science 10 right now, you will see some parabolas. Everybody cool? All right. Now, we're done with linear relations. Your work starts on page 168. Now, again, remember, the questions take up a lot of space because of pictures and tables of values, yes? It's not actually that much work, even though it goes all the way to page 170. All right, now, tomorrow is cumulative day. If your grades were not what you would have liked them to be on exponents and radicals and polynomial multiplication and factoring, what should you be doing right now? Practicing that if you wish to improve your grade. If you're perfectly happy with your grade or you don't think that you need to review that, what should you be working on? This. Page 168 to 170. When will I expect to see that done? Tomorrow's your cumulative. Woden's Day. Well, that's where Wednesday gets its name, from Odin, the god, the Norse god. Now, yes, Anthony Hopkins is Odin in real life too. The same guy that ate that man's liver with fava beans and a nice Chianti. Anyone? Silence of the Lambs, Hannibal Lecter, nothing. Greatest murder movie ever made. Silence of the Lambs, scariest bad guy ever. Thor or Odin. Nothing. I ate his liver with a Chianti and a nice with fava beans and a nice Chianti because he's a cannibal. Nothing. Silence of the Lambs, Oscar-winning movie. Nothing.
I've heard of it.
How do you people even get up in the morning? Oh, I know. It wasn't 3.5 hours long with computer-generated special effects. People actually had to act. That's why you haven't seen it. Sorry, my fault. All right. No, I didn't. Silence of the Lambs. Every Marvel movie. Yes. Now, listen. I have given you a crap ton of work, right? 4 pages of text or prepare for your exam tomorrow. What is the only assumption I can make if this room gets loud and out of control? That you need not work on this. It must be done. You need not prepare for your cumulative. You're ready for it. Which means, what is the only thing left for me to do this block? Give you that quiz because you must be ready for it. Right? Go. Yes, of course. Are you on Ramadan right now?
Yeah.
You are doing it?
Not now.
It starts.
It started already.
It started already?
Yeah, but I'm not gonna do it
You're not going to do it?
right now because I can't function in school.
Oh. I could see that. DCBA. Yo. Do I know how much what? A lot of money. A lot of money.
Monday, May 6th. We are going to start with the National Anthem, so please stand up.
That's you too, Nathan. Planet Fitness is running a summer challenge for teens 15 to 18. It's a free membership from May 15th till September 1st. You will need a parent to sign so you can sign up, but then you can work out alone. A huge well done to both Abbey senior drumlines who competed in the provincial championships last Friday. Both groups performed well, and though the standings didn't favor you, there are many positives as a result. Thank you to everyone who was involved in helping throughout the day, and to those of you who simply had to put up with that much sound. This week is the KPU International Music Festival for both jazz and concert band students. Please get your permission forms to Mr. McDonald as soon as possible. Down on the field was a set of cards and some keys on a beaded chain. The senior boys rugby team competed in the BC Stadium Series against Argyle on Friday night. The boys scored early and often, defeating the Pipers 72-5. Josiah Ravelli, Luke Pearson, and James Catlin each scored 2 tries, while Daniel Wilton, Ryan Street, Discrete Singh, Ethan Laurie, Connor Merrer, and Paul Fisher all scored 1. Ryan Street added 6 conversions. The men of the match were David Coronado and Daniel Wilson. The boys' next game is on Thursday against the #1 ranked South Delta Sun Rebels in the first round of the Fraser Valley playoff. You can't take a test.
Hey, Brad.
Tests back to me if you have one to look at, please.
Continue until Tuesday, May 14th at lunch in Mr. Women's Room, A107. This is an opportunity for you to choose a table and who you would like to sit with. Max 10 people per table.
Ryland.
Come ready with a list of names.
Thank you.
Also, please ensure you have paid all school fees and purchased a prom ticket. This is mandatory in order to sign up for a table. Please continue checking the Facebook page Abbey Grad 2019 for the most updated information as we approach the last few events of your grad year. One key with 3 club membership tags attached has been turned into the office. Reminder to physics students, the Playland trip is coming up this week, May 9th.
Is that wide to the 4th or 9th? On the bottom right, in the middle.
Mondays 11 to 5, Wednesdays 8:30 to
4,
and Fridays 8:30 to 11:40. Culture Club is meeting at lunch at the Sweeney Center classroom today.
I guess you're dismissed.
Please see Mr. Sharkran in the office at lunch for pickup. Kaya Kingma, Jennifer Best, Caden DeBoer, Zach Langfield, Aidan Peters, and Matthew Wicks. The following students need to report to PAC today, right now at lunch, in room A209. Jonathan Blackwell, Riley Blanche, Mia Bolton Trent, AJ Bulfurai, Dagan Brar, Bradley Buchanan, Jaskarn Chima, Yikai Cheng, Kiara Topek, Joshua Dela Cruz, Mark Destura, Amrit Dillon, Erlyn Deldilo, Diego Duran, Lydia Flores Salazar, Blake Fonseca, Harkarn Gill, Javon Graywall, Faith Warner, Daniel Jakubowicz, Reed Johnston, Martin Kiao, Nicholas Kenny, Siama Colt, Jaya Malay, Francis Manalo, Ming-Chi May, Kevin Morales, An Ewan, Vicky Yome Olabode, Joey Parisian, Cody Pope, Jonathan Fuente, Gerline Rekar, Nick Brendelich, Hannah Rowan, Jadu Soleil, Mavis Schmidt, Sage Schwab, Yama Shear, Ethan Sidal, Jagadeep Sidhu, Carmen Joke Sidhu, Kervin Preet Singh, Manroop Singh, Mikey Somerville, Bella Santini, Saya Apple, AJ Beer Venable, and Wu Zhang Zhang. Have a great day, Panthers. You are now dismissed for lunch with your teacher's permission.